All right, so let's look at the summation properties, and we're going to also look at the summation rules. So we have four properties that are listed, and we have here the sum of C, okay, where I is equal to 1. It goes from 1 to n. So what this is saying that the sum of a constant we call C equals the product of the number of terms in the summation n and the value of the constant. For example, I'm showing the rule only. I'm not going to evaluate any of this of the properties, but I want to show you how the properties work out here. So here we have, to show you the first property, we have the sum of 5 as I goes from 1 to 40. So the 5 is our constant. So what we're going to do is take the constant C, which is 5, and multiply it to the summation of n, which is 40. So you're saying here 40 times 5. So this is the first property where we're going to multiply that constant. It says to the product of the number of terms and the summation, which is called n. So we're multiplying those together. Now the next property, B, it says here we have the sum of C times a sub I as I goes from 1 to n. And what we're going to do is take this constant C and factor out that C, or it says factor out of a summation. For example, we have here the summation or the sum of 3 times k as I goes from 1 to 5. So what we're going to do, we have 3, which is our, if we thinking about or talking about variable expressions, this would be our uh, coefficient. But here, this is the constant. We're going to factor out the 3 and then times it to the summation of, or the sum of k as I goes from 1 to 5. That's the property B. Now properties C and D. It says here the summation of A sub I plus B sub I as I goes from 1 to n, what's taking place here to get the solution, what is equal to, and it also holds for minus. It says that the summation sign can be distributed across the terms of a sum or difference. So we're going to take that summation sign and we're going to distribute that. For example, we have here the sum of k squared minus k plus 2 as I goes from 1 to 10. So what we're going to do is take this summation and we're going to distribute that 3 times. So then we have here the sum of k squared as I goes from 1 to 10 minus the sum of k as I goes from 1 to 10 plus the sum of 2 as I goes from 1 to 10. So we're going to take this summation, we're going to distribute. So let's work some examples, and then we're going to look at the summation rules and talk about those. So for example, let's look at the example that you have on your page here. And actually, before we look at this example, where we're going, it says use the summation properties to evaluate the following series. We have the sum of 4i plus 4 as I goes from 1 to 4. Let's talk about the rules first, and then we'll come back to this particular example. So the rules. So what happens when we have the sum of I, and it can be any variable. It doesn't just have to be I. I is what we're focusing on here. It can be K, it can be J, it can be any other variable. But here we have the sum of I as I goes from 1 to n. Well, we don't know what n is. So how we're going to set up our I is that we're going to set it up where this summation is equal to n times n plus 1 all over 2. So yes, you will have to know the formula, the rules for the summation, as well as the properties. Now, what happened when we have the sum of I squared? Okay, when that variable is being squared as I goes from 1 to n, we have here n times n plus 1 over, excuse me, not over, but times 2n plus 1 all over 6. So we're going to be working with this. If the variable is cubed, what is equal to the summation of that? It's equal to n squared times n plus 1 squared all over 4. So yes, you will need to know the following rules here as we complete some of the examples.